The title is Reorganized Topic Modeling for Microblogging Data.
Hello everyone, I'm today's presenter, Yijin Chen, and I come from National Cheng Kung University. Today my topic is reorganized topic model for microblogging data. We know that microblog is very popular these days, but if we just apply the topic model directly on the microblog, will cause some problem because the short text. So we try to propose some solution. And the following is my outline. First is the introduction. We will talk about the motivation and background and the related work about the topic model. And then is our ROLDA methods and the experimental result and conclusion. So it's an introduction. The background is that the internet media deliver people thinking by using text, like Wikipedia and Twitter, Facebook. Everyone could post something on them. But there will cause some problem, like because they are too large of these texts, so we couldn't find what we are really interested in the short time. So they will have some tool to do the document summarize, like the topic model, for example. The topic model is a tool to summarize the context. It has been proposed in 1999 as the PLSA, and also the LDA, the more famous one, in 2003. So what's the idea of the topic model is that it uses the document generation process. It's just like human writing. If we are going to make an article, we will have some thoughts. We will have several topics we are going to write. And then we find some word to describe this topic and put this word together to form a document. So the same as the topic model, we just try to figure out what kind of the words we use and the related topic it is. So what's topic, for example? In this document, we have several topics, like the green one is the topic GAN, and the blue one is related to social. So we just use to count the amount of the word co-occurrence together and find out what's the most related topic it is. But they still have some problem of this kind of model because in the short text, so there will be not enough words. Like this is an apple, only 4 words, so we couldn't know the apple is important or not. So we couldn't find this article's topic. So our motivation is trying to figure out this problem. So because from the LDA, it's a document label topic. That means it's just used in a single document. It will lack of the co-occurrence information. So we could try out to use the global words. That means use the whole corpus, not just just single document. So what we're going to do is each row is a document, and then the red one is the word that we are going to find the co-occurrence. So we could find the word in some document, and then if we find the co-occurrence word, just put them together into another document. That's we call a virtual document. So by this duo, we could find several co-occurrence words and to form a bigger one document. So that's what we're going to do. So, and we talk about some related work. About the topic model for the normal text, we could have 2 kinds of the topic model. The first one is the vector space model, known as the LSA, and being posted in the 1998. but it has some problem that the cost of the singular value decomposition is too high. It will cost lots of the time and memory. So we consider other topic model is the probability model, as the LDA we mentioned before. But it still have some problem that each word is independent to others, and the relation between the topic is weak. It's not reasonable while comparing with the human writing style, because we won't put the words that is independent, it's no relation together. And while we apply the LDA model, it requires a well-structured long article. So if we put down the short text, they will not work so well. But it still have some topic model in the short text. Like this one, the Brighton topic model is being posted in the 2013. The idea of the Brighton topic model is use the Brighton. What Brighton means is to use the word pair that's co-occurrence together. For example, like I visit Apple store, visit Apple and visit store, they both appear together, so we could call them Brighton. So it use this kind of Brighton in the global word co-occurrence to build the model. Because it's global word, so it's the global, so it could overcome the problem that's in the short text. But it still have another problem, is that it will be dominated by the common word that will appear very often, so will be some noise. And there's another way to use in the short text, that we could use the external source, like the hyperlink or some related article, or use the same author's document, because we know the same author will have the same writing style, but it still have the problem that it is very domain specific. So if the document we find through chain is not so related with our original document, the model will become worse. So, and next one, we talk about our reorganized method. We have some example that we have the original document. First one is to remove the stop words. And then we try to do some reorganize, like the fruit, for example, this word is co-occurrence with the apple and banana. And we just put the word that co-occurrence into the virtual document. And then is another, follow this rule and find in the document 2, document 3, and to form the virtual document, and then it's other words. Then our virtual document will become like this. But before we put it into the LDA model, we are trying to set some ratio to remove some noise, because not every word we put it in the virtual document is highly related. So we use the NP&I to set the ratio. The NP&I is just like a point-wise mutual information, and it's find out the relation between the two words. If we set the ratio that's is not larger than the ratio, maybe it's goal related, so we could just try to remove the outs. And there's 3 advantages of our LDA. We could extend the length of the document. So like the Twitter, for example, the average word is 5.92, but if we try to put in the virtual document, it will become longer to the 3094. It's 6 times longer, will make the learning become better. And while we apply the NP&I score, can reduce some noise. Next one, we show our experimental results. Our 2 data sets is the Twitter and the ET State news title. While the Twitter will have many noise, like the wrong spelling or some emotional word or some informal word. But while the news title will be more formal, and it has the specific category. So while the Twitter, we just extract the English Twitter with the top 50 frequent hashtag. Why we use the hashtag is as the ground truth, because or the author, while she or he posts something on the internet, she use the hashtag that will relate it to the article and could be defined as its topic. And the following is the Twitter document is 50,000 and the domain is 50. And the next one is the news title, that's the Chinese news title, and it has the category like political, international, entertainment, just like the normal news title. And because it's Chinese, so we use some Chinese word segment. And it's about 20,000 document and 25 domain. So our experimental said that the first problem we meet is how to evaluate the quality of the topic model. Because topic model is the unsupervised learning, so it won't put out some label. So we should apply other application to evaluate. Like we could use the clustering, use the highest probability, and we define the topic. We divide it as the topic of this cluster. And the second one is the classification. We could use the reduced feature to get the reduced feature matrix and put that into a classifier. We use the classifier linear to find out stable. And we compare with other basic model like LDA, Visual Unigram, and BTN to find out whether we perform better. And our evaluation criteria is the first one, purity, to find out whether there's noise in the cluster. And the second one is the normalization mutual information to find out the output cluster label with the gold standard label. And the last one is the rank index. Used in the cluster and classification, it will penalty the both positive and both negative. And the following is our results. We could see that our ROLDA is performed better in these three criteria. And the next one is about the number of topic with the accuracy. We could see that our ROLDA performed better, and while the topic getting more, is more than 60 in the topic, the ROLDA will perform better because the ROLDA is more flexible and it could acquire the more diversity of the topic. And the next one is the ratio in ROLDA. That's, we set the ratio to 0.125. It will perform better while we remove some noise. So it's better than we did not set the ratio. And then the next one is the news title. But we get the different results. In the news title data sets, the BTN is performed better. Within the problem is that the BTN is used by turn, so it's used a pair. So in this kind of the formal article, it will make it perform better. While the ROLDA is more flexible, so it will make the words in the topic more diverse and couldn't discover the real topic. And then we find out the top 10 topic word related to the most hashtag jobs. The ROLDA will have the most related. And in the ET today, in the festival, the BTN and the ROLDA most performs well. And the last one is our conclusion. In this paper, we propose a solution for the LDA topic model in the short text. And our methods have two advantages. The first one is no external data. We don't need to find some document and worry about that maybe it's not so related. And the second one is that we do not modify the original topic model. So if we just apply it in the other topic model, we don't need to modify, so it could be easily used. And our future work is to try to improve our ROLDA, like to remove the redundant document. Maybe we don't need to use so much document, and to find a better algorithm while to do the co-occurrence. So, and it's a reference, and it's my presentation. Thank you for your attention.
Okay, thank you. Any question? Any question?
You have told that you have used some classification techniques. What kind of techniques you have used? The techniques is not clear. Classification techniques. I say.
Classification. We use the classifier in Linux.
Okay. And how it works? And what is the computation parts for this to classify your the texture or whatever you
Sorry?
the computation parts is not available, that's why I'm asking. How it, I mean, you have given something theta or something. Theta as the reduced feature matrix. How it works? How it works?
You mean how it was performed?
Yeah. And okay, my another question is, by other application clustering, you are saying that especially unsupervised clustering, is it? Have you used unsupervised clustering on this part? Non-hierarchical clustering. Unsupervised clustering. You told us that you have used the clustering also, since you don't have the label. Okay, so for finding the label, you have taken the classification techniques. Okay, thereafter that you tried I mean, you used clustering techniques for cluster it by using the what? By using your label. So what the clustering, I mean, what kind of clustering you used? Unsupervised clustering. May I know about the unsupervised clustering, the name of non-hierarchical clustering which you used for clustering the things by using your labels?
Sorry, I don't know the details.
Okay, thank you.